Okay, so number 11, another intermediate value problem. We're going to see if it holds or does not hold. Our function that we're given is this circle. If you don't see the circle now, go ahead and write y is equal to the square root of 25 minus x squared. Square both sides. Then move the x over by adding it. And we get the following. Circle at 0, 0 center with a radius of 5. If I drew this, because of the way it was given to me in function form, it did not say plus or minus. It just gave me the positive one. So I'm only going to graph the positive y values, which in this case will be the top, quadrant 1 and 2. So this is negative 5, this is 5, and this is 5. Because of the radii where r is equal to 5. Alright, so now what we're going to do is, we're going to go through the rule. Well, first let's finish with our graph by graphing 1, 2, 3. So we're going to graph this right here. Our established domain is between negative 4.5, which is roughly about here, all the way to a positive 3, which is probably here. So we're looking at this interval here. We're saying there must possibly exist an x where these two lines or functions will intersect. The y is equal to 3 function will intersect with this function here. Alright, so let's go through our rules. The very first one is this continuous on this established domain that we're looking for? Well, in fact, it is. Looking at this, we're going to say f of x is continuous on negative 4.5 to 3. Another way we could solve for this domain of where it existed, remember when you have square root functions, you could just set the radicand, that's anything underneath the radical sign, greater than or equal to 0, and then solve for x. So that 25 is greater than or equal to x squared. And then whenever you're going to do this, you're going to say that solving this is the inequality. You'll have a plus or minus answer. So let me go ahead and write this. Less than or equal to 25. You're going to square root both sides, and you have this is less than or equal to a positive 5. And then you have the negative 5 because you have a plus or minus answer. Let me show you real quick. 25, x is equal to plus or minus 5. So that negative 5 is going to cause our inequality to flip. So that if we're looking at this, our domain lies where it exists anything less than 5 and anything greater than negative 5, which of course is showing that domain because it's right here as far as on the graph. Alright, so that's just an extra little algebra just to refresh. If I go to rule number 2, rule number 2 is going to say we got to establish that f of a does not equal f of b to make sure our theorem holds and we can move on. Well, what is f of a? F of a is the y value that I will get when I plug in my a value into this function right here. So if I plugged in negative 4.5 and I squared it, I'm going to get a positive answer of whatever that is. A positive whatever 4.5 squared is. Well, 4.5 squared is going to be 20.25, and we're going to say 25 minus that, take the square root, that is f of a. So that's going to come out to 4.75. 4.75 is my f of a. Is it not equal to f of b? So now let's go ahead and put our b value in to the equation. So that 25 minus 9 is going to be 16. The square root of that is 4. Obviously, they do not equal each other, so I can continue. I'm going to go to rule 3 now. Now, k is equal to 3. Now, here comes that part that I was showing you on number 10. Okay? If I'm looking at, to make sure that the theorem holds or does not hold, this k must be between f of a and f of b. Okay? If I say let k equal 3, that's f of c is equal to 3, I must first recognize that this lies in between these two given y values here. Okay? Does that 3 lie in between 4 and 4.75. It does not. It's not in between. 4.75 would be here, 4 would be here, the 3 would be way down here. By the theorem or the intermediate value theorem, I must first assign a k that is existing between those two values. Then I can see how it would yield between negative 4.5 with the x values and positive 3. Then I could see that is going to create this. Because I'm not given a k, a y value that exists between those two values that I'm looking at as far as the established a and b value, the theorem does not hold. Okay? I did prove that it was not equal to, but this is a step that is frequently forgotten. Okay? I need to find something that is in between those y values. Not in between these x values, but in between the y values that we got as f of a and f of b. So because k is not in between, because k is not basically on the interval between 4 and 4.75, or you can say is not between 4 and 4.75, we cannot continue with the theorem. The theorem does not hold. It has to be established in between f of a and f of b. Theorem does not or doesn't hold.